here we have question 7, and what's interesting is that this now asks you for f double prime. Notice the notation is not just f prime x, but we call this f double prime. So what does that mean? They need you to get the second derivative. So at the moment, this might be something fairly new to you because you're just introduced to first derivatives. But yes, second derivatives do exist as well. How do we do this? In order for you to get a second derivative, you need to get the first derivative first, meaning you need to get f prime x. So f prime x is the first derivative. Then only you can get f double prime x, which is known as the second derivative. Okay, so let us focus on getting f prime x. Let's get the first derivative. Now, to get f prime x, we are given f of x as the square root of x. Firstly, we do not have any brackets, but we do have a surd. So you know that you need to rewrite your surd as an exponent. A square root as an exponent is 1 over 2. Next, we check for variables in the denominator, which we do not have, so we can go on to differentiating. So f of x becomes f prime x. And when we differentiate x to the power half, remember the exponent here, the coefficient here is 1. Take the exponent, multiply with the coefficient, a half times 1 is still a half, and minus 1 from the exponent. So a half minus 1 is negative 1 over 2. Now we've differentiated, we've used the correct notation, and you can make sure that you have positive exponents. Now here's the thing. If the question asked me for f prime x, then I would get the positive exponent because that would be my final answer. But since we are not done, since we still need to get f double prime, we need to get the second derivative. I'm not going to complete this and make it a positive exponent because I would have to move it to the top again. So now that I have my first derivative, I'm now going to get the second derivative, which is f double prime x. Now, how do we do this? We take the exponent and we multiply with the coefficient. Now, here's the thing, especially when you have a fraction format. The coefficient of x is not just 1, but instead it's 1 over 2. And that's extremely important. This is something that learners often mess up because we used to just taking it as the number in front as a coefficient, but instead it's, and look at it this way. If you had to block off x, say you blocked off x with its exponent, whatever number is left, that is the coefficient. So the coefficient here is 1 over 2. Now let's follow through with the step. We are taking the exponent multiplied by the coefficient. So negative a half times positive a half gives you negative 1 over 4. We are now going to minus 1 from the exponent, so negative half minus 1 gives you negative 3 over 2. So this is our second derivative. We have used the correct notation. We have f double prime x, and now we need to make sure that we've got positive exponents only. So to make the exponent positive, we are going to move x with its exponent to the denominator. Okay, let's do that. So the negative 1 will stay in the numerator. The x now goes in the denominator next to 4, and its exponent now becomes positive 3 over 2. So making an exponent positive is quite basic. All you do is take the variable from the numerator and put it in the denominator, and automatically the exponent changes sign. So this is your final answer. This is the second derivative of f of x.